The first type of bond that we'll discuss is called ionic bonding. In this type of bond, valence electrons are transferred from one atom to another. So, like in our last example, when sodium reacts with chlorine, sodium gives its valence electron to chlorine. It is transferred from one to the other. The compounds made from ionic bonding, called ionic compounds, are usually hard, brittle, and have high melting temperatures. Sodium chloride, or table salt, is a common example of an ionic compound. All ionic compounds are actually called salts, but most are not edible. Now, since electrons are transferred from one atom to another, some atoms will have more than they started with, and some will have less. Atoms are usually neutral, meaning that they have an equal number of positive protons and negative electrons, but after an ionic bond forms, this changes. One of the atoms involved lost an electron and now has more protons than electrons, so it has a positive charge and is now called a cation. The other atom now has more electrons than protons, so it has a negative charge. This atom is called an anion. Since the cation and anion are bonded together, the total number of electrons and protons in the compound are the same, making the compound neutral, but the individual atoms now have a charge. Just like the poles of a magnet, atoms with opposite charges attract, and like charges repel. So cations attract anions, but push away other cations, and anions do the opposite. As a result of this property, when you get a bunch of these compounds together, the different sides push and pull on each other, and eventually arrange themselves into evenly spaced geometric structures called crystals. The shape itself is actually called a crystal lattice. Cations are usually metals, and anions are usually nonmetals. So ionic bonds usually form between metal atoms and nonmetal atoms. When you're dealing with elements that need to gain or give away more than one or maybe two electrons, transferring electrons becomes much more difficult. These types of atoms tend to share instead. When two atoms share electrons, they are in a covalent bond. When carbon with 4 valence electrons bonds with 2 oxygen atoms, each with 6, they share electrons to get up to 8. Each oxygen shares 2 with the carbon, giving the carbon 4 more, and now a total of 8. And the carbon shares 2 of its valence electrons with each of the oxygen atoms, giving each of them 2 more, and a total of 8. This kind of bond usually forms between 2 nonmetal atoms, such as carbon and oxygen, and the compound made from such a bond is called a molecule. All organic compounds, such as the proteins, lipids, and carbohydrates that your body is made up of, are molecules held together by covalent bonds. Molecules can be visualized by using electron dot diagrams or Lewis structures. We won't spend a lot of time working on these, but we will try to get the general idea. These diagrams show the atoms involved in the molecule using the symbol from the periodic table and then dots to represent the valence electrons. Looking at methane, or CH4, we see 4 hydrogen atoms and 1 carbon atom. Carbon has 4 valence electrons, but wants 8, and hydrogen has 1, but wants 2. So we have to arrange the atoms so that by sharing certain electrons, they each can complete their outer energy levels. The dots drawn between 2 atoms are being shared by those 2 atoms. So looking at the example, we can see that carbon is sharing 1 of its 4 electrons with each of the hydrogen atoms, and that each hydrogen atom is sharing its 1 valence electron with the carbon. The carbon, since it is getting 1 from each hydrogen, now has 4 more and a total of 8 valence electrons. The hydrogen atoms, since they have each gained 1 from the carbon, now have 2 each and also have complete outer energy levels. Since all the atoms have complete outer energy levels, it has no charge and is now a stable molecule. A pair of electrons being shared, usually one from each atom, form one bond. Atoms can share more than one electron though, so some molecules are held together by double or even triple bonds. To make the diagram simpler, you can replace a pair of shared electrons with a bar. A bar in these diagrams represents two electrons being shared, or in other words, one bond holding the two atoms together. Two bars between two atoms would mean that they are sharing a total of 4 electrons, probably 2 from each atom, and are held together by a double bond. 3 bars would mean 6 shared electrons and a triple bond. The bonds between different atoms and placement of free electrons will make some diagrams take on variable shapes. This happens both in the diagrams and in real molecules, because the electrons involved have the same charge and want to be equally spaced.